Now it's time for the video presentation of Dr. Gulnaz. Parveen, having huge experience in the fields of academia and administration with 15 years experience in Pakistan. She worked as Director Academics, Registrar, Head of Department, Director FAD and Director QEC, Teaching and Research in Agricultural Biotechnology and Plant Pathology Lab, University of Karachi, Women University Azad Kashmir and Women University Sawabi. She is multitasking personality involved in quality enhancement, women leadership and training while basic area of specialization in botany, plant pathology. Kindly play her lecture.
Bismillahirrahmanirrahim. I am Dr. Gulnaz Parveen, Chairperson and Associate Professors in the Department of Botany, Women University Sawabi. Today my topic is the formulations of the nanofertilizer from orange peel, which use against the root rotting fungi and enhance the growth of the Vigna radiata plant. Nanofertilizer are basically defined as the material, usually in the form of the nanoparticles containing the macro and micronutrients that are delivered to crops in a controlled mode. And as we know that the agricultural sectors of the world is facing a serious challenges such as the decrease in the crop yield due to the attack of root rotting pathogens, to use the nanofertilizers in a modern technology that is effective in the management of the pest in agriculture. So the use of the nanofertilizer is the best approach, which is cost effective, environment friendly and provide the balanced nutrition for crops to achieve the full yield productivity. The aims and objectives of my research is to investigate the presence of the nanoparticles in orange peel and utilize it to increase the germination and enhance the growth of the Vigna radiata plant by reducing the infection percentage of the root rotting fungi. Now here is the graphical representations of my research work. Like, we synthesized the nanofertilizer from orange peel and tested its potentials for promoting the growth of the Vigna radiata and reducing the populations of the root rotting pathogens. So nanofertilizer extract was subjected to physical and chemical analysis for characterizations. Transmission electron microscopic TEM indicated the spherical nanoparticles which size range is different, while the X-ray diffractions analysis, the peaks were observed. Different peaks were observed which represented the similarity with urea standard peaks. The synthesized nanofertilizers contain the phenol, steroids, triterpenes and xanthoproteins. In a greenhouse experiment, the nanofertilizer extract was given to the seeds of the Vigna radiata. The research demonstrated that increasing the dose of the orange peel extract enhanced the germination percentage. Not only this, by positively influencing the plant growth characteristics. Meanwhile, a high concentrations of the orange peel amended successfully reduced the colonizations and infection percentage of the root rotting pathogens like Fusarium, Macrophomina, Rhizotonia, etc. when compared to the positive and negative control. During this research, the different orange samples, fresh and healthy oranges, were collected from different areas of the Ghazi, and that is located in this near to the Sawabi area. Dry examinations. Oranges were dry examined with the help of the torch to separate the disease in the healthy ones and prepare the powder from the orange peels. The orange peels were removed, shed dried and converted into the fine powder.
The methanolic extracts was prepared from the orange peel powders, and this was screened or examined for the presence of the different types of the bioactive phytochemicals, and by the help of the screening methods like the phenol and phlobatanins, steroids, triterpenes and xanthoprotein test was performed and checked presence of all these bioactive compounds in the orange peel powder. For further analysis, the samples were prepared for the observations of the nanofertilizer that are present in peel powders. The peel were then grinded in blenders and then add some amount of the potassium hydroxide. Boil this solutions for 30 minutes and allowed to cool. Also added some amount of the urea and citric acid dropwise to maintain the pH of 5, and after this obtaining the slug was dried at 105 degrees centigrade temperature and then grinded to the fine powder again, and the product was then subjected to the physical and chemical analysis for the identifications of the nanoparticles in it. So the measurements of the nanoparticles that were present in the samples were checked by the help of the different tests like TAM, transmission electron microscopy, XRD, X-ray diffractions methods. So in the TAM test, samples that contain the nanoparticles were identified and measure it. And another test was the XRD for the further confirmations of the nanoparticles because the different peaks were observed. And then after confirmations of these nanoparticles that were present in the orange peel powder, the screen house experiment was performed, and that was the pot experiment that was carried out to check that effect of the nanofertilizer prepared from the orange peel powder in a screen house experiment. Here is some results of the phytochemical screening. Like presence and absence of the different bioactive compounds, and the presence of the different colors indicating the presence and absence of these compounds. Like indicating presence of the phenol was the presence, while the phlobatinins was absent, and the steroids were present, triterpenes was present, and the xanthoproteins was also present in the samples of the peel powder. Here is the results of the TAM, which observed at 100 nanometer and 200 nanometers range, and different particle sizes under the range of the 100 nanometers were observed, which was indicating the presence of the nanofertilizer or nanoparticles, which make the peel powder as a nanofertilizers. Here's the pictures, another slides showing the tables which indicating the size of the particles of samples. Here is the results of the XRD. The peaks were observed at the 2 theta value, and the different peak was observed in this results, which was well matched with the peak of the urea. So the full width half maximum of the peak has been used to conclude the particle size. This is the results of the screen house experiments when the nanofertilizer was applied in the soil, and which effect on the growth of the radiata plants. And it is clearly observed, you can clearly observe in this picture that the negative control and the positive control means that some fungicides were used to compare our fertilizers from this, but the fertilizer effect was the more than the positive control also. So positive control, it was the ideal control, but and the negative control means that we do not apply any fertilizer or treatments in these plants. So the clear observations was recorded that the growth were enhanced by the additions of these fertilizers in the soils. So these fertilizers not only enhance the growth of the plant, but also reduce the infections of the different root-rotting pathogens like Macrophomina fasciolina, Fusarium solani, and Fusarium oxysporum. So the different species of the Fusarium were controlled from these nanofertilizers. So this have the multidimensional effect, like it can not only enhance the growth of the plant but also reduce the infections of the pathogens. So here's the clear graphs which are showing the reducing effect of the pathogens by applying the treatments. Next slide please. Here is the overall conclusions of my research, that the orange peel extract was prepared from the dried orange peel powder and analyzed through phytochemical screening, showing the existence of the different phytochemical compounds such as the phenol, steroids, triterpenes, xanthoproteins. Then the characterizations of the nanoparticles was performed through transmission electron microscopy, which revealed the presence of the various nanoparticles that range in size from 18 to 61 millimeter at the resolutions of 100 nanometer. The X-ray diffraction patterns of the nanoparticles using orange peel extract were shown also shown in the above described figure, the peak were observed at 2 theta value, and different peak were observed which was well matched with the peak of the urea. Similarly, the nanofertilizer was applied to check the growth of the Wigner radiata under a greenhouse experiments that not only enhance the growth of the plants but also suppress or reduce the populations of the root rotting pathogens, which was indicated in the graph, thus acting a cheap and effective method to produce the growth and development of the plant in the field of the agriculture. Thank you so much.
I want to invite Dr. Adnan, who is Director of IM Group of Researchers and always being a great sport for us, for his conclusive remarks.
Assalamu alaikum, dear valued guests, participants, and esteemed team. Is the 4th International Conference on Life and Chemical Sciences with the theme From Lab to Life, Emerging Trends in Biological and Chemical Sciences come to an end. I want to express my sincere gratitude and pride for the success of this event. On behalf of the organizing committee, I want to thank our guest speakers, participants, and especially the dedicated team that worked hard to make this conference happen. Our goal focused on providing valuable education and raising awareness through research has come to life through the lively discussion and knowledge sharing during these enlightening days. Organized by the IM Group of Researchers, this conference provided a common ground for the students, researchers, scientists, and professors in life sciences and chemical sciences to share insights, experiences, and the latest advancement in their fields. The objective we set for this conference were not just met but surpassed thanks to active involvement of everyone present. We successfully encouraged collaboration between experts in biological sciences and chemistry, opening doors to innovative solutions for global challenges, discussions on healthcare, drug discovery, sustainable practices, and the exploration of chemistry, of nature, and biomolecular sciences have undoubtedly advanced scientific understanding, paving the way for future breakthroughs. I want to express my appreciation for the commitment shown by participants in promoting ethical chemical research, environmental awareness, and safety measures. This conference has not only been a platform for intellectual exchange, but also a catalyst for building a community of responsible researchers dedicated to making positive impact on society. Special thanks to our distinguished guest speakers whose expertise enriched the conference, and to every participant who actively contributed to the discussion. My gratitude also goes to the organizing team whose careful planning and ensure the smooth flow of events. I am confident that the knowledge shared and connection made during this conference will go beyond these walls and make a lasting impact on the laboratories, classrooms, and research institutions represented here. As we part ways, let's carry forward the spirit of collaboration, innovation, and ethical responsibility that defined the 4th International Conference on Life in Chemical Sciences. Thank you all for your unwavering support, and I look forward to future endeavors that continue to push the boundaries of scientific exploration and social impact. Thank you all.